Hi there, this is a video about graphing polynomials. The first thing we got to do is talk about a lot of vocabulary associated with graphing polynomials. The first thing I'm going to talk about is the word degree, and this is your largest exponent, okay? And knowing what your largest exponent is going to help us determine the shape of the graph. The next thing I want to talk about is the end behavior. All right, and the end behavior is what the graph does as x gets big and as x gets really small. And the way we look at end behavior is we look at a couple of things. You're going to have four different scenarios. You get a scenario where your degree is even and your leading coefficient, all right, is positive. All right, and I like to think of the function y is equal to x squared, where my largest exponent is even and my number in front of my leading variable is positive, okay? If that's the case, your end behavior is going to go up to the right and up to the left. All right, the other option is if your degree is even, but your leading coefficient is negative, all right? And I like to think of the graph y equals negative x squared. All right, then I'm going to go down to the left and down to the right. And what this means is that as x gets really, really big, your graph is going to go up, all right, to the right. As your x values get very, very small to negative numbers, your graph is still going to go up, all right? Same thing here, down and down, all right? Let's talk about the two other scenarios, all right? And that's if your degree is odd and your leading coefficient is positive. All right, I like to think of the graph y equals x cubed. All right, and so we're going to go up to the right and then down to the left. If your degree is odd and your leading coefficient is negative, I like to think of the graph of y equals negative x cubed. And that's going to go up to the left and then down to the right. All right, so those are your four options for end behavior. And so it's important that we identify this, all right? So, you know, when we're graphing polynomials, I'm really going in the order in which we, you know, graph these and what we got to look for in order to put all this together, all right? So we start with the degree. We then look at the end behavior. The next thing that we look at is a thing that we've already talked about in the previous video called zeros, okay? And this is where the graph crosses the x-axis. All right, this is really important. All right, and we've got two different kinds of zeros. You can have real zeros, okay, or you could have complex or imaginary zeros, okay? Real zeros is where your values are going to cross the x-axis. Okay, complex zeros are solutions, okay, but do not cross the x-axis, okay? And so that's the idea. All right, so that's something we'll look at. The other thing we got to look at is this concept of multiplicity. And this is the number of times a factor appears in a function, okay? And if your multiplicity is odd, all right, then you're going to be crossing the x-axis. If your multiplicity is even, then you're going to bounce off the x-axis, okay? The last thing I want to talk about is the y-intercept, all right? So your y-intercept is not only where the graph crosses the y-axis, but you find it by by letting x equal 0 and then solve for y. All right. The other thing that we also know is that it's the constant in a polynomial. All right. So it's the number that's not associated with a variable. So it's like the standalone number. Okay. So let's do this. All right. I want to graph the following function. All right. And we're just going to kind of put all this stuff together. Let's graph the function f of x is equal to x minus 1 quantity squared times x plus 3 times x minus 4 to the third power, okay? And this graph is in factored form, okay? And I wanted to have it in factored form for you guys to see how all of this stuff works, okay? The first thing that I want to do is I want to determine the degree of my polynomial. Now, it's a little tricky when it's in factored form, but what I know is that, you know, if something's in factored form, notice how I've got like x squared times another x. Like if you were to multiply all this stuff out and FOIL everything, you know, x squared times x and then times an x cubed, all right, then you would get x to the 6th power. Okay, and if you've got x to the 6th power, then we can identify that our degree is 6, which is an even number. All right, so that leads us to our end behavior. All right, so end behavior, as we look at this, all right, I know that my, my degree is even, and my leading coefficient, again, if I multiply all this stuff out, x, you know, positive times a positive times a positive, results in a positive number. So my leading coefficient is positive, okay? Therefore, my end behavior is going to go up to the left and up to the right, all right? The next thing I want to talk about are the factors, okay? The factors are going to help us determine where we cross the x-axis. So let's look at the factors of this polynomial, and that will lead us to the zeros, okay? Now, as we look at this, we've got 3 different factors. We've got x minus 1, okay? We've got x plus 3, and then you've got x minus 4. All right, I'm disregarding the exponents for now. That will help us in just a second. We'll identify those, but let's just find the zeros. So once you've got something in factored form, x minus 1 is equal to, x is equal to positive 1. All right, x plus 3, it's always the opposite. Your 0 is at negative 3. And when you have x minus 4, your 0 is at positive 4. All right, now as I look at the exponents, it's going, how many times does this appear? So this factor, x minus 1, appears twice. So this has multiplicity 2. All right, the x plus 3 factor, that occurs once. That's multiplicity 1. And then x minus 4, that factor is occurring at the multiplicity of 3. All right, so what I want to do from here, multiplicity 2 means that we're going to bounce at that 0. Multiplicity 1s means we're going to cross at that 0. Multiplicity 3, because it's odd, means we're going to cross. So even means we bounce, odd means we cross. All right, so putting all of this stuff together, let's graph this. Now, this is just a general idea of what the graph is going to look like, all right? If you were to put this into Desmos, you're going to have a crazy y-intercept and kind of a crazy graph, but I just want to get the general shape of what's going on. That's the goal, okay? So let's use these zeros to plot points on our x-axis. So I'm going to plot a point 1, 2, 3, 4, 1, 2, 3, 4. So I'm going to put a 0 at positive 1. I'm going to put a 0 at negative 3 and 1 at positive 4. All right, now the other thing that I want to do, so that's kind of the first thing I do, is I plot my zeros and then I look at my end behavior. Okay, the end behavior tells me that on my left side we're going to go up to the left, and on the right side we're going to go up to the right. Okay, at our x minus 3 factor, we are crossing the x-axis at that factor. All right, so I can cross through, And then I've got to connect that with my point over here at x equals 1. Now this point means we're going to bounce off. All right, so we're going to cross through. We're going to come up to this point. We're going to bounce off and continue to go down. We're not going to go through at that point. And then the next thing I want to do is cross through my value at x equals 4, and we get a graph like that. So this is just a general shape, okay? And it's important that you're able to know what's happening over at all these points. Are we going through those points? Are we bouncing off? And that will extend on into higher levels of math, like calculus, where we can, draw a lot of conclusions based on what's happening at these zeros. Are we going from positive to negative, negative to positive? Are we changing the y values at those points? And so it's really important that we understand and take a graph like this and be able to draw it. Okay, so let's look at another example. All right, so on this example, we've got the function f of x is equal to negative x to the fourth plus 4x cubed minus 4x squared. The first thing I want to do if we're trying to graph this is let's identify our end behavior. All right. We know that our degree, our largest exponent here is a 4. All right, so therefore our degree is even. And then our leading coefficient is a negative 1. All right, so leading coefficient is a negative. From here, we then know that our end behavior is going to go down to the left and down to the right. Okay, that's the first thing that we need. The second thing that we need are the zeros. Okay, and from here, what I want to do is I want to set my polynomial equal to 0 and solve this equation for x. All right, so what I want to do in this case is factor, okay? Because and I'm looking at this, it's degree 4, so it's got a lot of, higher polynomial or higher degree polynomial. But what I notice is that each of my factors or each of my terms here have a common factor of x squared. Now I'm going to do this. I'm going to factor out a negative x squared. All right, and it's kind of because my leading coefficient is negative is why I'm doing that. But then we're left with x squared minus 4x and then plus 4. All right, from here, I can factor this polynomial. All right, so I've got 0 is equal to negative x squared. And then this is going to factor to x minus 2 times x minus 2. All right, and because this occurs twice, I'm going to write this as negative x squared times x minus 2 quantity squared. All right, so I factored this thing completely. And what I've done is now I have my factors, okay, and I'm going to write this out as negative x squared. I'm going to write this as x minus 2 quantity squared. And I want to turn those into zeros, okay? If I set this equal to 0 and solve this equation for x, I get 0. I could divide both sides by negative 1. I'm still going to get just x squared is equal to 0. I take the square root of both sides. I'm still just going to get x equals 0. So that's my 0 for that one. Now over here, this one's going to be just x is equal to 2. All right, take whatever's inside of here, set it equal to 0, solve for x, that's what you get. When x is 0 here, the multiplicity is 2. All right, same thing here. For this factor of x minus 2, my multiplicity is 2. From there, I can then conclude that we're going to bounce. All right, and we're going to bounce here. All right, now the one thing I want to do here is determine our y-intercept. All right, so our y-intercept, we let x equal 0. We're just going to find f of 0. And when I plug that in, we're going to get negative 0 to the fourth plus 4 times 0 cubed minus 4 times 0 squared. And from there, that's just going to give us 0. So f of 0 is equal to 0. And let's go ahead and put all this information together in graph, okay? Because what we know is that we have zeros at 0 end at 2, okay? And we're going to bounce off. But we have to use the end behavior to draw our graph. All right, so we're going to have our graph go down like that, and each of these are being bounced off at those values, and so then we can just draw our graph this way, okay? And that's the idea. All right, let's look at one more example. Okay, on this next example, we want to graph the function f of x equals negative x cubed plus x squared plus 4. All right, and from here, what I want to do is let's quickly talk about the end behavior. And so from here, what we know is that our largest exponent is 3. So our degree of this is odd, and our leading coefficient is a negative 1. All right, so leading coefficient is negative. Therefore, our end behavior is going to go up to the left and down to the right. All right, so that's our end behavior. Next thing we want to do is to calculate our zeros. All right, so from here, let's do this. Let's set our polynomial equal to 0 and solve this for x. Now, what I notice is that this is a degree 3 polynomial with 3 terms. This isn't something that we can readily factor as is. So we want to use synthetic division, and in order to use synthetic division, we want to graph this real quick to see where do we start with the synthetic division process. So let's put this into Desmos real quick. So as we plug this into Desmos, what we find out is that our graph crosses at x equals 2. All right, so that's a starting point. So one of our zeros is at x is equal to 2. All right, so this is going to be our starting point for synthetic division. So from there, we're going to use 2 for this, and then we're going to plug in our values. So we've got negative 1, 1, 0, because we don't have a term with an x, so our coefficient is 0, and then 4. So let's drop this down. We got negative 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. 2 times negative 1 is negative 2. 0 times plus negative 2 is negative 2. And then this gives us negative 4, and that gives us a remainder of 0. So the first step in factoring this is we get x minus 2, and then you're left with negative x squared minus x minus 2. All right, and that's how we would want to factor that. From here, I don't think that this is factorable, so let's use, we've already got one of our zeros here. We know that that's going to be multiplicity 1. But let's go ahead and solve that using the quadratic formula. And so from here, my a value is negative 1, b value is negative 1, c value is negative 2. So let's plug that in. Let's see what kind of solutions we get from this. We're going to go opposite b, so 1 plus or minus the square root of negative 1 squared minus 4 times a, which is negative 1, times c, which is negative 2, and that's all going to be over 2 times negative 1. All right, so from here, we get x is equal to 1 plus or minus the square root. We've got 1, negative 1 squared is 1. All right, and then negative 4 times negative 1 times a negative 2 is going to be a minus 8. All right, and then this is all over negative 2. So under our radical, what you find is that you have a negative 7. So 1 plus or minus the square root of negative 7 all over negative 2. And so what you end up getting here is you get 1 plus or minus I times the square root of 7 over negative 2. Now this is going to yield us a complex solution. All right, and so because that's complex, this is not going to, this does not a real 0. It's a complex 0. So you end up having a, this is not going to cross the x-axis. Okay, and if you remember back to our graph, we only had one spot where we did cross the x-axis. All right, but it's important to go through this so that you understand that, okay, yeah, because I end up finding all of the zeros, even if they're complex, that's fine. All right, my 0 is still x equals 2, and that's multiplicity 1. The last thing I want to do here is calculate our y-intercept. All right, so I want to find f of 0. And when I find f of 0 of this function, we have 0 cubed, so negative 0 cubed plus 0 squared plus 4. All right, and that's just going to give us a value of positive 4. All right, so that's important that we've got that. We've got our 0 here of x equals 2. Let's put this all together. That's all the information that we need. So let's plot our y-intercept at 4, our x-intercept at 2, and let's think about our end behavior. We go down to the right, all right, and then we go up to the left. All right, and so we come up here and we can, make it look like a cubic function, but that's the general idea of what the graph looks like, and that's all you would need to put, all right, for something like that. So hopefully this all makes sense, putting all that stuff together to graph polynomials. It's pretty important for us once we get to calculus. So, yeah, please reach out if you have any questions. We'll talk to you soon. Thanks. Bye.